Okay, guys, example number 2 here. And it says find the LCM, the least common multiple, of 9xy squared and 15x squared y. Okay? Now, I don't know if I was clear enough on that first one, so I want to make sure that I clear this one up here, Nicholas. So let's look at this one. I need the prime factorization. So what's the prime factorization of 9, Rex? 3 and 3. Okay? And then I need x, y, y. Okay, does everybody agree that's the prime factorization for that first one? We're good there? Now, Spencer, what's the prime factorization for 15? And they're both prime. So I've got 3 times 5 times x times y. Now, guys, the key idea for the least common multiple is I need to be able to make both of these numbers out of the prime factorization of the least common multiple. So that means that I need, for the first one, for this for the 9xy squared, I need a 3, I need another 3, I need an x, I need a y, and I need a y to make it, right? I need all of those things. So I can just list them straight off. Now, let's look at the other number. I need a 3. Do I have a 3? Okay, so I don't need to add another one. I've already got a 3. But I also need a 5. Do I need a 5 down in the least common multiple? Do I have a 5 there yet? I don't, so I need one. Okay, so I'm just going to put a 5 down there. So now I can make the 15. I need an x. Do I have an x? Okay, but I need another x. Do I have another x? No, so I need to add another x down here. Okay. I also need a y. Do I have a y down there? Yes. Okay, so now I can make both of these numbers from what I have down here. Okay? So you can see here's a 3, here's a 3, here's an x, here's a y, here's a y. Then for this one, I've got a 3 already. I've got a 5 now. I've got an x, I've got an x, and I've got a y. So I can make both of those numbers from that. Does that make sense? Now we just push them back together. We just cram them back together. What is 5 times 3 times 3? Anybody? 45. Is it 45? Good. 5 times 3 is 15 times 3 is 45. Look, x times x is x squared. Y times y is y squared. That's it. That's the smallest number that they both go into. Does that make sense, Henry? Does that make sense, Rex? Yes. How about you, Miles? Yeah. Taggart? Yes, sir.
Is there a way to check, like plug it in?
No, not for this. There's really not a way that we would check here. I mean, you can divide them both, right, to make sure that they go into them. But it's not like an equation that we get to plug in and see if it works. Okay? All right, let's look at the next one.